this section, 6-7, we'll solve rational equations. A rational equation is an equation involving ratios of polynomials. And of course, the main problem is that there'll be denominators all over the place. And you get rid of them by multiplying both sides of a rational equation by a common denominator. So we just get rid of all the denominators and just left with the polynomials. So for example, 1 over a equals 1/3 minus 2 over 3a. This is denominated as a, 3, and 3a. The lowest common denominator is 3a. So we multiply throughout by 3a. That will cancel all the denominators. So we get 3 over a, this term, equals, this term is 3 over 3 minus, this term is twice 3a over 3a. 3a over a, that's 3, equals, 3 over 3 is a, minus twice 3 over 3a cancels, so 3 equals a minus 2. Add 2 to both sides of this equation and get 3 plus 2 equals a, so a equals 5. Or how about this? 18 over y plus 1 plus 2 over 5 equals 4. This equation is denominated as y plus 1 and 5, so we multiply throughout by their product. And 18 times 5y plus 1 over y plus 1 plus twice 5y plus 1 over 5 equals 4 times 5y plus 1. All right, after a bit of simplifying and stuff, you get 90 plus 2x plus 2 equals 20y plus 20. After we transpose the, let's say, the 2y to the right and the 20 to the left, 90 plus 2 minus 20 equals 20y minus 2y. And then after a bunch of steps, which I'm skipping here, you get y equals 4. All right. Now here, p plus minus 1 over 2 plus 1 equals 3 over p. Denominators are 2 and p, so we multiply throughout by 2p. So this term is becomes p minus 1 times 2p over 2 plus this term is 1 times 2p equals 3 times 2p over p. Okay, well, after canceling 2 and distributing, and after canceling p and multiplying, you get p squared minus p plus 2p equals 6. Do some transposing and combining terms. P squared plus p minus 6 is 0. This factors to p minus 3 times p plus 3 times p minus 2. Product equals 0. If a product equals 0, one of these two factors must be 0. If p plus 3 is 0, then p is negative 3. If p minus 2 is 0, then p is 2. So those are the solutions. P equals 2 or p equals negative 3. Now there's a potential problem. Sometimes if you try and substitute back just to check, you'll find that you were dividing by 0. And that's not allowed. It's caused infinite or indefinite quantities, which can be annoying. So sometimes a root can be extraneous. It yields a division by 0 when substituted into the original equation. All right, here's an example, and you can review here. 3 over r plus 12 over r squared minus 4r equals negative 7 over r minus 4. And then factoring everything out, you get 3 over r plus 12r times r minus 4 equals negative 7 over r minus 4. Now, if in this original equation, if you substitute r equals 0, we get a 3 over 0 and a 12 over 0. It's infinite. We don't like that. If we substitute r equals 4, then this is again a 12 over 0, and this is a negative 7 over 0. Again, we don't like that. So we'll call those, if you ever get r equal to 0, then it's extraneous and there's no real, and it doesn't work as a solution. All right, fine. All right, common denominator is r and r minus 4 multiplied by their product. For this, after canceling an r here and r minus 4 here and r minus 4 here, you get this equation, which you simplify. You get r equals 0. But this is extraneous. The only solution that seems to work is one that gives you infinities if you plug it back. So it's not allowed. Or well, I don't know. You can say that there's no solution, or you can say that they're only extraneous solutions. It means pretty much the same thing. Depends on what you feel about how you feel about infinity. So in these rational equations, you have to test any root that you find just to make sure you don't wind up with a division by 0. Okay, x minus 4 over x minus 3 minus x minus 2 over 3 minus x equals x minus 3. Okay, first of all, these are the same, only in opposite order. So if we switch this to an x minus 3 and change the sign from minus to plus, it's equally valid. X minus 4 over x minus 3 plus x minus 2 over x minus 3 equals x minus 3. Now, if we don't want to divide by 0, then we have to say x is not 3. All right. Now, to simplify, we multiply throughout by x minus 3, which is another reason why you don't want to multiply by x. You don't want to have x equal to 3, because then we'd be dividing throughout by 0, and that would make it, make a root by trivially. All right, anyhow. So multiplying through x minus 3, these denominators disappear, and we're left with x minus 4 times x minus plus x minus 2. Now you have x minus 3 times itself. All right, combine like terms, 2x minus 6. Expand x minus 3 times x minus 3, x squared minus 6x plus 9. From here, we subtract 2x from both sides, add 6 to both sides, get 0 equals x squared minus 8x plus 15. All right. This, a polynomial, a quadratic, would factor, and we get 0 equals x minus 3 times x minus 5. Their product is 15, their sum is negative 8. And okay, so if product is 0, then one of these factors is 0. So x is 3. So x minus 3 is 0, so x is 3. Or x minus 5 is 0, so x is 5. Now I have to check both of them. If we try x equals 3, and remember I have to go back into here, whoops. Well, it doesn't work at all because, you have 3 minus 3 here and 3 minus 3 here. You division by 0 and get infinities. That's no fun. So we throw out x equals 3 root as extraneous. We try x equals 5, though. I remember in the original equation, 5 minus 4 over 5 minus 3 minus 5 minus 2 over 3 minus 5. That equals a half minus 3 over negative 2, which comes out to 2. And the right, x minus 3, this 5 minus 3 is 2. These check out, so it works. So there's one non-extraneous root, x equals 5. All right, we have some examples. Negative 10 over t plus 3 equals 1 minus 11 over t minus 3. Oh, t plus 3 and t minus 3, my apologies. Okay, because we don't want this t plus 3 to be 0, t can't be negative 3. Because we don't want this t minus 3 to be 0, t can't be 3. So these are two already excluded values. Okay, so we multiply throughout by the lowest common denominator. That's t plus 3 times t minus 3. So this times this is all this equals 1 times all this is all this. This times this is all this. For this first term, we cancel the t minus 3, and we're left with minus 10 times t minus 3. Here's sum times difference. That's the difference of squares. T squared minus 9. Minus here, the t minus 3 is canceled. Minus 11 times t plus 3. Okay, so expand this, multiply negative 10 throughout, minus 10t plus 30. It equals t squared minus 9. Now here we'll have to watch out, there's this negative sign, so we're going to multiply throughout by negative 11. So you get negative 11t minus 33. Okay, here's the equation. To zero out the left side, we add 10t to both sides, subtract 30 from both sides, and you get 0 equals t squared minus 9 minus 11t minus 33 plus 10t minus 30. Okay, you combine like terms, these t terms, these constant terms, and you get 0 equals t squared minus t minus 72. To solve, we can factor. We need two numbers whose sum is negative 1 and whose product is negative 72. What works are 8 and negative 9. 0 equals t plus 8 times t minus 9. All right, then, one of these factors is 0. If t plus 8 is 0, then t is negative 8. If t minus 9 is 0, then t is 9. And here are two roots. And neither of them equals plus or minus 3, so they're all allowable. So these both check. Wow, here we have 3 over s minus 2 plus s minus 14 over 2s squared minus 3s minus 2 minus 4 over 2s plus 1, all that equals 0. Okay, first we factor 2s squared minus 3s minus 2. After some work, it turns out to be 2s plus 1 times s minus 2. We have an s minus 2 here and here. We have 2s minus 1 here and here. Okay, because we don't want 2s minus 1 to be 0, s is not negative a half. Since we don't want s minus 2 is 0, we have s is not 2. All right, to get rid of denominators, we multiply throughout by the lowest common denominator. That's 2s minus 1 times s minus 2. Here, there, here, and here equals 0. In this first term, the s minus 2's cancel. In the second term, the 2s minus 1 and the s minus 2's cancel. In the third term, the 2s plus 1's cancel. So we're left with 3 times 2s plus 1 plus s minus 14 minus 4 times s minus 2 equals 0. Okay, after we distribute this and here and combine like terms, 3s minus 3 is 0. Add 3 to both sides, 3s equals 3. Divide both sides by 3 and s equals 1. And that's not forbidden in the original equation. So s equals 1 is a solution. Now here they have one of those, what do they call them? Look-alike problems. They sort of look alike, only they're phrased slightly differently, and as a result have entirely different kinds of answers. Here we're just combining these terms and getting an expression. Here you have an equation which we're trying to solve. Here, 11 over 12 minus 3 over 2x plus 4 over x is what? Well, okay, this has denominators 12x and 2x and x. The lowest common denominator, well, it has an x, has a 2 and a 12. 12 combines both. So 12x can cancel against all these. So put over common denominator, 12x. We have 11 minus 3 plus 4 times the compensators. For 11, we go from 12 to 12x, we compensate by multiplying by x. For 3 over 2x, we go from 2x to 12x, so we compensate by multiplying by 6. From x to a 12x, it's 12 times bigger, so we compensate in the numerator by multiplying this 4 by 12. 11x minus 3 times 6, that's minus 18, plus 4 times 12, that's plus 48. Combine terms, and you get 11x plus 30 over 12x. This was a sum of terms, and we're asking for the name of the sum, and there it is. This is a bit different. This is an equation, which we're supposed to solve. 11 twelfths minus 3 over 2x equals 4 over x. Since we're dividing by x here and here, to avoid dividing by 0, we have to say that x is not 0. Lowest common denominator is 12x, like we had up here. So 12x times 11 twelfths minus 3 times 12x over 2x equals 4 times 12x over x. Right here, the 12s cancel. Here, the 2x cancels against the 12x, leaving a 6. Here, x cancels against that. And after a bit of algebra, it's 11x minus 18 equals 48. All right, solve by adding 48 to both sides. 11x equals 48 plus 18. So 11x equals 66. Divide both sides by 11. 11x equals 66 over 11, so x equals 6. And that's not forbidden from the original equation. So solution x equals 6. All right. This next one involves, well, I suppose it's the application is photography, where two lenses in a row, their the relation of their focal lengths is this: 1 over combined focal length equals 1 over first focal length plus 1 over the second focal length. Okay, first of all, what is f in general? And second, if S1 is 5 inches and S2 is 60 inches, then what's f? All right, now let's multiply this throughout using what I call the rabbit rule. So 1 over f equals 1 times S2 is S2 plus 1 times S1 is S1 over S1 times S2. 1 over F equals S2 plus S1 over S1 times S2. To find F, it's enough to take the reciprocal of both sides, which I denote by this loop-de-loop arrow. So this flips up to an F. This flips up to S1, S2 over S2 plus S1. Product over sum. In particular, if S1 is 5 and S2 is 60, then F is 5 times 60 over 5 plus 60. That's 300 over 65, about 60/13ths of an inch. So 4 and 8/13 inches. All right.